Okay, congratulations. Well, we're ready to start the first lab. I hope you're excited. So, in this lab, we're going to be creating a serverless transcoding pipeline in AWS. And these are the pieces of the system that we're going to be building and connecting together. So, when somebody comes to the website that we're building, they're going to be able to upload a video just like they're on YouTube. So, they can sign in, upload a video. That video is going to go up to Amazon to S3, and that's the source video file. That might be a really high resolution. That could be a 4K video, for example. But then our transcoding pipeline in our system is going to downsample that or transcode that video into different formats that make it friendly for people to be able to access on the web, maybe from their laptop or from their mobile phone, their cell phone, however they want to access it. So we're going to have that in a few different formats, and that might make the video a lot smaller to consume, say on a mobile device or a slower internet connection. So in this lesson, we're going to start by building some of the transcoding pipeline. We're going to build these two pieces here. This pipeline is going to transcode the video files into these new web-friendly formats and put them on S3, somewhere that our customers can then access them. So we talked earlier about the 5 principles of serverless architectures. And what we're going to build now relates to a couple of these principles. The first is use a compute service to execute code on demand. Now, this is probably the most important principle. Run your code in a stateless compute service, like Lambda. Don't be silly, don't run or manage a server. Your goal is usually to solve an interesting business problem, not to fiddle around patching Apache, for example. Now, you can write functions to carry out almost any task, such as reading and writing to a database, calling out to other functions, performing a calculation and returning it. And the best thing is that you only pay for the time that your code executes. This means that you're building milliseconds and not hours. And it massively reduces your hosting costs because you're not paying for servers to sit around idling and waiting for requests. And in fact, due to a very generous free tier, we didn't pay for Lambda at all during the first year running A Cloud Guru. That's pretty amazing. Now, there might be scenarios where a server is still needed to do something, but these cases should be few and far between, and as a developer or a solutions architect, you should avoid managing your own servers if possible. The other principle that relates to this lab, this is my personal favorite. You should design push-based event-driven pipelines. They're really powerful. They allow you to extend the architecture really simply, and they look like magic. An event-driven pipeline is one that kicks off thanks to some kind of event coming in, and then it continues to propagate further without any additional user input required. So one event triggers another, and it's almost like a chain reaction. Building event-driven push-based systems will often reduce cost and complexity. You won't need to run extra code to poll for changes, for example. You don't need to write code that's sitting around waiting for something to finish. Your code gets triggered when that thing finishes. And it potentially makes the whole user experience for your customer a lot smoother. And it goes without saying that while event-driven push-based models are a really good goal, they might not be appropriate or even achievable in all circumstances. Sometimes you'll have to implement a Lambda function that polls the event source or runs on a schedule. Okay, so in this lesson, we're going to build the transcoding pipeline. So someone comes onto the website and they upload this file. Now, we're not going to do the website upload at this point. But what happens with the website upload is that it pushes the file into S3. So in this lesson, we're just going to manually upload these video files to S3 using the AWS console. Later, we'll connect the upload straight from the web browser. So we'll put the files in S3, and then we will configure S3 to trigger a Lambda function anytime a new file arrives in that S3 bucket. Now, this is a Lambda function that we'll create and we'll upload ourselves, and we'll show you the code in the lab. Now, the Lambda function itself is responsible for using Amazon's Elastic Transcoder service to create a transcoding job. Now, Elastic Transcoder is Amazon's media transcoding service, and it's set up specifically to transcode video files from one format to another. So it's absolutely perfect for what we need. We just use the Amazon SDK, which is the software development kit in Node.js, to actually call Elastic Transcoder and configure the job. So we tell Elastic Transcoder, here's the video that we want to convert. We give it the address, the location in S3, and it will go off, it'll grab that source video, and then it will transcode it into a range of different formats. Now, when Elastic Transcoder completes transcoding that video into a new format, it will put the output, so the transcoded version, into a destination S3 bucket. So that's a different S3 bucket that we specify. So we'll create that one, and then as the different versions of this video are created, they will land in that destination S3 bucket. So you'll see a 480p version, maybe a 720p, 1080p, all of the different versions and MP4 files. So to set this up, we're going to be using 3 different AWS services a lot in this lab. We're going to be using S3 for file storage, IAM for security policies, and Lambda for function execution. We'll also be setting up Elastic Transcoder.